AET 105, Chapter 1, Problem 6. This is an example of a unit conversion. How long in seconds will it take a car traveling at 60 miles per hour to travel the length of a football field 100 yards? So how long means you're looking for an amount of time. Time equals distance divided by velocity. So either convert the distance d from miles to yards or yards to miles. The solution chose yards to miles. So we're going to take 100 yards, 3 feet in a yard. So we're multiplying it by essentially 1 because these two values are equivalent. And we want to end up with miles. So 3 feet in a yard, 1 mile is 5,280 feet. So when you multiply 10 times 3 times 1, and divide that one by 1 times 5,280, you get 0.0568 miles. And then the book chose to convert to miles per second. And the reason why is because convert hours to seconds for relevance. If you don't, you get a really small number in hours. So we take 60 miles per hour, which is what we were given, times 1 hour divided by 60 minutes, times 1 minute divided by 60 seconds. So it'd be 60 times 1 times 1, which would be 60, divided by 60 times 60, which is 3,600. So 60 divided by 3,600 is 0.0167 miles per second. And then T equals D over V. So you take your distance divided by your velocity, and then you get miles cancel out, and this is miles per second, so a second goes up into the numerator, and you get 3.40 seconds. Problem 14. Throughout the world, the majority of countries use centigrade rather than Fahrenheit. This can cause problems for travelers not familiar with what to expect. To alleviate this problem, the approximate conversion is simple. It's typically used. Degrees Fahrenheit equals 2 times degrees C at plus 30. And then this is the exact formula here. Degrees Fahrenheit equals 9/5 C plus 32. This is just easier to do in your head. So part A says the temperature of 20 C is commonly accepted as normal room temperature. Using the approximate formula, determine in your head the equivalent Fahrenheit temperature. So you use this formula. You take 2 times 20, which is 40, and add 30 to it to get 70, as shown here. Part B, use the exact formula and determine the equivalent Fahrenheit temperature for 20C. So using the exact formula, 9/5 C plus 32, you take 9/5 times 20, divide by 32, that ends up being 68 degrees. So how do the results compare? Is it valid as a first estimate? It's very close. Yes, it's valid. And I'll repeat parts A through B for a high temperature of 30C and low of 5C. So 30C would be 95 or 90 using the approximate formula, 86 using the exact, and 5C would be 40 versus 41. So it's close enough just for a rough calculation.